Hello team, this is going to talk about microservice granularity. So how much functionality should we have in a microservice? So a functionality might be broken down into different components, so we can have smaller components to provide a given functionality, or we can have a bigger component that provides multiple functionalities. And there's no single solution that works for all cases, so there are different implementation decisions and I have to pick one. So let's go back to our image processing application example. So how should we implement a transforms service? So in the original example, I had a single microservice that implemented all of the transforms. So you could ask a rotate transform or a resize transform, and they were all implemented in the same microservice. So here you have the original design with a single large transforms service. Another design would be to break down the transforms service into each individual transform. So you could have a smaller rotate microservice that rotates images and another resize microservice that resizes images and flips them horizontally or vertically. So we can break down the transforms service into smaller components. And we could even have a different approach where we have a single transforms service that image processing app will interact with, and then the transforms service will use other microservices that each implement a different transform. And again, there's no right or wrong, there's just different options and you have to pick one. So going back to the amount of coupling that we have in applications, so we've seen that monolithic applications are more tightly coupled, but even monolithic applications that might have different levels of coupling. They might have different modules and allow plugins, for example. And the same thing happens with microservices. So microservices are usually on the loosely coupled end of the spectrum, but microservices can be a little bit bigger than others, and they might have more functionality or not, depending on how they were structured. And when we decide the size of a microservice, we have to analyze this trade-off between the granularity. So the smaller the microservice, the many advantages we get from finer granularity when doing auto-scaling, the teams can be smaller and so on. But as we have more smaller microservices, we get additional management complexity because we're going to have more microservices and there's going to be more interactions between them. So we have to decide where on this trade-off we want to be. So here's a list of 3 things that we can try when deciding the size of a microservice. So one thing is doing business process modeling, where we identify how applications are used and the steps in the workflow. For example, in the image processing application, the user might first open an image and then we have to render it. And then the user might apply different modifications to the image and then save it back. So we can identify these steps and then try to write one microservice for each step in the workflow of the application. It doesn't work for all applications, but some applications with well-defined steps that are usually performed in order, this might be one approach. Another approach is logical grouping. So we can try to identify common functionality that is used by many different modules. And then we can try to group this common functionality in a microservice so that it can be used more broadly. And then we can design interfaces that support these broad use cases from many different modules. And the third approach that can be combined with the previous two is adaptive refactoring of microservices. Because microservices are small, it's easier to iterate on the source code and modify it as needed. So we can refactor to split a microservice into smaller components or to join very small components into a bigger microservice. And we can also refactor to add new functionalities to existing microservices. So this is one way to evolve microservices and make them more manageable over time and more general.